Let's do a quick review of transformations and circular functions. So really the topic should just be called transformations because the way you approach transformations is exactly the same for any function you operate on. So the fact that it's circular functions shouldn't be like, ooh, this is something new or interesting. So find the equation of the image y equals sine x under the following transformation. So it's been dilated by a factor of 2 from the x-axis. So dilations from x change y. Dilated by a factor of 3 from the y-axis. Dilations from y change x. Translated 5 units in the positive direction of the y-axis. Not plus. 2y plus 5. And 2 units in the negative direction of the x-axis in that order. Okay, so that's x dash there, that's y dash. What I want to do is sub for y and x. So I'm going to say x dash is equal to 3x take 2, x dash plus 2 all over 3 equals x. Now it's solve for x, which is good because I want to sub for x. Now let's bang in y dash equals 2y plus 5, y dash take 5 all over 2 equals y. So our function is y dash take 5 on 2 equals sine of x dash plus 2 all over 3. Let's just finish it off, drop the dashes, and y equals 2 sine, y equals 2 sine x plus 2 all on 3 plus 5. You could split that one as well, so x on 3 plus 2/3, but that's fine as it is. So there's our transform function. Okay, dilated by a factor of 3 from the x-axis. Dilations from x change y. Translated pi units in the negative direction of the x-axis. Pi units in the negative direction of the x-axis, yep. Dilated by a factor of half from the y-axis. So dilations from y change x. So yeah, it's that. Comma 3y in that order. Okay, x dash equals x take pi on 2. And what I want to solve for x. So 2x dash plus pi equals x, and y dash equals 3y. Y equals y dash on 3. Right, so original function was, what was it? Can't remember. Y equals sine x. So it's going to be y dash on 3 equals sine of 2x dash plus pi, and y equals 3 sine 2x plus pi. What would we do to this function to make it look like this? Okay, so I know the answer to this by recognition. So this is going to be dilated by a factor of 2 from the x-axis, and it's going to be dilated by a factor of 1/3 from y. But what if you weren't sure? Right, so what we do is we go y equals, or from, y equals sine x to y equals 2 sine 3x. Now we get ready to pair these up where this is the original, this is the image. So I go y dash on 2 equals sine of 3x dash. Right, so y pairs with y dash on 2 and x pairs with 3x dash. Right, to get the transformations, what I need to do is put x dash here and y dash here. All right, so let's do y dash. So 2y equals y dash, so that's 2y, and x on 3 equals x dash, so x on 3. So what are the transformations? This one here is dilation 1/3 from y. This one here is dilation 2 from x. And make sure you guys are using the correct terminology. So dilation and axes, axes. So make sure you use the full word for that. All right, so what do I do to this to make it look like this? Now, this one's hard. All right, so I can't do that one by sight. So I'm definitely going to go from y equals sine x to y dash equals -3 sine 2x plus pi on 4 plus 1 with a dash there. All right, so let's get ready to pair these up. So I'm going to do y dash take 1 all over -3 equals the sine of 2x dash plus pi on 4. All right, let's pair them up. Y equals y dash take 1 all over -3 and x equals 2x dash plus pi on 4. All right, how does this work? What we do is x dash and y dash. So this thing here gives us the transformations to make x dash. So I need to make x dash the subject, and the same goes for y dash. So I'm going to go -3y plus 1 equals y dash. So it's -3y plus 1. This one here is going to be x take pi on 4 all over 2 equals x dash. So I'm going to rewrite that as x on 2 take pi on 8. I'm going to divide both of them by 2. All right, so now we can say our transformations. So this one here, let's start with x. We're going to say the first thing that happened was dilation factor half from y-axis. Then what happened is it was translated pi on 8 left. Okay, so that's those transformations there. All right, over here, what we're going to note is it was a reflection in x-axis, that's the negative. It was a dilation factor 3 from x and a translation 1 unit up, or 1 up. Right, note that those two transformations can be given in a different order, but this one has to be last. All right, state a possible sequence of transformations which have been applied to that to give us this. So we're going from y equals 4 sine 2x take 5. Nope. Take 5 to y equals sine x take 2. Okay, so let's get ready to pair these up. This time I have to do y dash plus 2 equals sine x dash. And this one here is not ready to be paired either. So that's y plus 5 all over 4 equals sine 2x. All right, now we're ready. So we're going to go y plus 5 on 4 equals y dash plus 2. And then we've got 2x equals x dash. All right, that was easy enough for the x's. All right, so remember what we're going to do. X comma y maps to x dash, y dash. I need to put x dash there and y dash there. Okay, so let's do the easy one first. X dash is equal to 2x. It's already ready to go, so we're just going to write that as 2x. So we can see that this is going to be a dilation factor 2 from the y-axis. What about this? All right, so the way we're going to do this is we're going to write this as y over 4 plus 5 on 4, and I'm going to subtract 8 over 4 equals y dash. All right, so now I'm going to write this as y over 4 take away 3 over 4 equals y dash. That's all right, but I'm going to just do that as y take 3 all over 4 equals y dash. Now let's fill it in. Y take 3 all over 4. Right, so now we can state our transformation, so let's formally do that one. So this is a dilation factor 2 from the y-axis All right, now first up here, y had 3 subtracted from it, so we're going to go translated. 3 units to the, no, 3 units up. And finally, it was multiplied by a quarter. So we're going to say dilation factor quarter from x axis, and we've got them. Okay, so there's some transformations questions as well. Not many, but some practice to keep your eye in.